Okay, so yesterday when I showed you on that quadratic solver that I had on my phone, and we talked about the 288, I said it's called the discriminant. We located where the discriminant was. I'm just going to flip back to yesterday's lesson just really quick, just to do an example. Let's just go back to this one for a second. I'm going to put this in my quadratic solver. So my A is 2, my B is -10, and my C is a +11. Let's solve that equation. Okay, so you can kind of see both of them here. So the discriminant is the 12. That's what it is, and that's what today's lesson is about. But if you look at the quadratic that we solved, do you see a 12 anywhere? No. I do.
Oh, yeah,
in the end. Where is it located? It's under the square root. So this thing here, what's under the square root is your determinant. Now, I mean, you don't have to go back and edit yesterday's notes, but just know that when we're talking about it, it shows up time and time again, and it's the thing under the root sign, and it tells us something really quickly. The discriminant will tell us how many roots we have. It won't tell us where they are, but it will tell us how many. So when we talk about the nature of roots, we talk about the discriminant. So if I take this will tell us what's under the root sign will tell us how many roots we have. And what's another word for roots? X what? X-intercepts, yeah. So going back to chapter 3, how many possible options do we have for x-intercepts? How many can I have? I could definitely have 2. So I could have 2 x-intercepts. What's another option? 0 x-intercepts and 1. So there's really only 3 options. You guys would agree? We could have 2, we could have 1, or we could have none, right? That's from chapter 3. So the discriminant, without graphing a vertex, without knowing if it opens up or down, the discriminant can also tell us if it has 2, 0, or 1. Okay, so this is what you're going to know. If the discriminant under the root sign is positive, we'll have 2 answers. If it's negative, we'll have no answers. That's where we're going to get the error in the calculator. Right? We did a question where there was a -20, and we couldn't go any further. And remember, I said you had to write no solution, so that we know that there's no x-intercepts. So if the discriminant is negative, we'll have no roots. And if the discriminant is 0, we'll only have 1 root. Got it? It's pretty easy. So if you're asked how many zeros a quadratic function has, why not deal with just the information under the root sign? So 2 different types of question. Where are the roots? That means you have to plot them. You'll use your whole quadratic formula for that. If I ask you how many roots, you're just going to use the discriminant here. So you could solve the whole quadratic formula, but why? That's extra work. So what's under the root sign is called the discriminant, and that is your b squared minus 4ac. This is not listed on your formula sheet. So it's not on your formula sheet. Not on formula sheet. But the quadratic formula is on the sheet. So this is on the formula sheet. And really the discriminant's just whatever under the root sign. So it's there, but it's just not identified. All right, so let's do our first example. Describe the nature of roots. If I ask you that, describe the nature of roots, what I'm really asking, how many roots? That's what I'm asking. I'm asking how many roots. I'm not asking where those points are. I'm just asking how many do I have? How many x-intercepts do I have? So again, I'm going to start this with a is 1, b is -6, and c is +7. Let's use just the discriminant. So we're going to have -6 squared minus 4 times 1 times 7. So I have 36 minus 28. And what do I get? What is that? +8. Do I care about the number? Not really. Like 8 doesn't mean anything. What's the important part of it? It's that it's positive, right? So, right, so it's positive, so it will have 2 roots. So the 8's important, I guess, kind of, sort of, but not to answer this question. What I need to know is my answer positive, negative, or is it 0? And because it's positive, that's how I get this answer. FYI, this is the answer to the question. If you leave it at +8, you get nothing for this. You have to tell me that there's 2 roots. Like, that's the answer. Because what's the question asking? How many roots? Are you telling me there's 8 roots? Well, that's not a quadratic function then. Easy peasy, right? It's not hard at all, but switching your brain between 4.2 and 4.3, that's the tough part. Can I flip? We good? Ooh.
So these terms roots just means discriminant, right?
Yep. Yep.
Is it possible to have 8 roots?
Not in a quadratic, but yes, in a polynomial function, for sure you can. It has to be a polynomial that has a degree of at least 8. Come to calculus and I'll teach you how to graph those. Okay, this question no one likes. FYI, it's going to show up on your quiz and it's going to, no, because you're not going to be, this isn't going to be on the quiz. This is going to show up on your test. Hint, hint, nudge, nudge. This question, this example. Not this exact same one, but you need to know how to solve these. Okay, so it says my quadratic here has 2 roots. So what do we know about the discriminant if it has 2 roots? It's positive. Okay, pretty easy, it tells me that. So it says, what values of m make this possible? Because I don't have a value for c in here, I only have a value for m. Everybody got one laying down here? Okay. Yep. All right, so we're going to make a statement. So the discriminant is positive. So really what we're saying is b squared minus 4ac, and we're going to write this as an inequality. It has to be positive. So what inequality would I use here? What does this have to be in order to be a positive number? No, this whole side here. I'm digging, and like I don't expect you guys to get this, so I feel kind of bad that I'm leading you down this road. what if I write this? Can you guys read inequalities? So inequalities started in grade 9, you graphed some in grade 10, and now we're going to do a little bit of work with them in grade 11. So what is this? What do we call this? That's the discriminant, right? The discriminant is greater than 0. Isn't that a positive number? Wouldn't you guys say that? Like, so if this were on a number line, here's 0, where's the discriminant? It's on the right-hand side, right? Now, does it include 0? No, how come? Right, but if the discriminant is 0, does it still have 2 roots? It only has 1. So it can't be equal to 0. Now, the reason why we use inequalities is because when there's not one right answer. If I said to you guys, what is a passing mark on a chapter 3 test? What's a passing mark? Okay, 50 is definitely 1. Is 90 a passing mark? Is 72 a passing mark? Is 50.5 a passing mark? Okay, so when I say statements like that, there's many answers, right? There's not just one answer. So we use inequalities to represent when there's many possible answers. So we're saying that the discriminant has to be positive. You guys know what the open circle means? Means does not include. If it was shaded in, it would mean that it includes 0. I'm trying to back this up because it makes a lot of sense to me, and you guys are like, I don't know, this is all feeling a little weird, but it will get better, I promise. Okay, so we know that the discriminant has to be greater than 0. So we're going to have lots of answers. We're not just going to have one answer. That's why we use an inequality sign. Okay, so what do we know A is? 1. What's B? What is C? But we're trying to find the value of C. Do we know what it is? No. So we're going to write, you guys with me so far here? Because we're trying to find what those values of C are that are going to satisfy this equation, or this inequality, sorry. Okay, so let's put those in. So I'm going to have 8 squared minus 4 times 1 times negative m. And remember, we have to use this because we need it to be positive. So that's going to be greater than or equal to 0. So 64 minus negative 4m is greater than 0. So we have 64 plus 4m is greater than 0. What do I do now? This is grade 9, and we never told you why you'd use this, but you're going to use it in situations like this. How do I solve this? I solve it exactly like it would be an equation. So what do? I got to move the 4m, right? Or I got to move the 64. Which one do you want to move? Oh, you guys are crazy. I love it. How can we pick the 64? The 4m stays positive, and I'm not dividing by a negative. What happens to an inequality when you divide by a negative? You flip your inequality, right? And you guys need to write that note down somewhere. I'll show you in a second. So m is greater than, what's 64 divided by 4? What? 16. Is it a positive 16 or a negative 16? Negative 16. So m has to be greater than a negative 16 for the discriminant to be greater than 0. Make sense to everybody? Sorry? m has to be greater than 16 for the discriminant to be greater than 0. And how do we know that the discriminant had to be greater than 0? Because the question told me it had 2 real roots. This is a tough one. This is going to show up on your test. Can I just pop over to this one here for a second, because I just want to do some rules of inequalities. So let's say I moved the 4 instead. If I divide by a -4, what that does, and no one remembers this rule, it flips the inequality. So if it was facing, the pointy part was facing to the right, now the pointy part is facing to the left. Let's read this. What does this say? M is greater than -16. I want you to read this. M is greater than -16. It's the exact same answer, but lots of people forget to flip the sign. So if you don't remember this, it's really important that you write it down. So the only time we flip it, so notice I divided by a positive coefficient here, I didn't flip the inequality. We only flip that inequality if it's a negative coefficient that we're dividing by. We don't flip the sign for add or subtract or moving from side to side. The only time we flip the sign is when we're dividing out a negative coefficient. All right. So, what? Not moving? Okay.
The answer's what we didn't read.
They're both the exact same thing. When I read an inequality, I always start with the variable. Wherever the variable is, I finish with the inequality. So when you're going to start the inequality, read it, m is greater than -16. When I read this one, start with the variable, m is greater than -16. It's the exact same sentence.
So if you don't put the inequality, would you still mark it wrong even though the answer is right, but it's just you didn't put the inequality?
You would be completely wrong. You would get no marks on this if you had no inequality on it.
No, if you didn't flip it.
You would lose a full mark.
Even if you get the answer?
Even if you got a -16 and the sign was the wrong way, that's a full mark deduction. Because that's a whole different set of values. Because this number line says -16 and m has to be greater than it. So those are those values. You would have said, if the sign was the other way, you would have been on this side of the line. So that's a whole full mark. What?
But you just said those two are the same.
Yeah, they are.
Yeah, so it doesn't matter which way you do it?
No. As long as you get the same answer. Like I thought you were talking about if you didn't flip the inequality from here to here. If you didn't flip the inequality from here to here, that would say m is less than -16, which is an incorrect answer. Okay, last example. Last example. Describe the nature of roots for this one. And the only trick to this one is, what should I do first before I start picking my A, B's, and C's? It's got to be equal to 0. So that's the only trick to this question. Minus 5x plus 9 equals 0. And I assume you guys are okay with me not showing the math, that I'm adding 9 to both sides, because that's really what I'm doing. If you want to show that step, you're more than welcome to. I think though that as we become more confident with this stuff, so okay, you guys tell me how many roots this question has, or this quadratic has. How many roots? Yeah, do it on your own. Yep. Which one are you talking about? But you can't add a negative 5x plus just a constant of 9. Those aren't the same type of terms. Right? If they were both x's, totally, you'd be 100% correct. But because they're not the same type of term, you can't combine them. Can I show you guys my math? And don't forget to answer the question. It's not good enough just to do the math, but you have to answer the question. How many roots? So if you haven't written down that there's 2 roots, 1 root, or no roots, then you have not answered the question. Okay, I'm going to show you my math. And you guys see if it matches yours. If you are not putting your brackets around -5 when you square it, you really need to. Because if you... Hein, did you just... Did he not put his brackets around? Is that why you're hitting it? So if you're not doing... Like, that's the proper way. That's the proper mathematical grammar to do that. So if you're not putting the brackets around, you need to get into the habit of doing that. And that is being picky, but it is also grammatically correct. Okay, everybody get that? Everybody good? Sort of, kind of, maybe?